Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.6, day 1, entitled Modeling with Equations. And when you model with equations, basically that means you're dealing with word problems. So we're going to create a model to work our way through those word problems. And today we're just going to focus on problems with interest and area. Now, when we are reading through a word problem, there's some steps that your book recommends. By now, you're very familiar with these steps and how to work through a word problem. But the very first step is to make sure you know what you know and know what you don't know. So identify the variable. And then sometimes you can translate the problem right from words into an equation. Sometimes word problems have a whole sentence that tells you the exact equation they want you to use, and you can translate it piece by piece. Sometimes you might know a formula, or it might make more sense to draw a picture or make a table. But once you have that information translated, then you want to set up your model and make an equation based off of that model. And then you go through and you solve the equation, and of course, check your answer. So let's take a look at some word problems where we can practice those skills. And in example 1 here, we're renting a car. A car rental company charges $30 per day and 15 cents per mile for renting a car. Helen rents a car for 2 days and her bill comes to $108. So how many miles did she drive? So again, if you need to take time and reread through this and talk it through in your head until it makes sense, you do that. The information that we know is that the company charges $30 per day and they charge 15 cents per mile. We know Helen rents the car for 2 days and we know her total is $108. What we don't know is how many miles she drove. So that's what we're finding. So there's not a set formula that we need to use for this. It's kind of just multiplying and adding and getting our total. So we would take the charge per day, and you could write this out in words if you wanted to. You could take how much they charge per day times the number of days, and then you would take the charge for the miles times the number of miles, and those would be your two quantities that you would add up to get your total that they charged you overall. So we know that they charged $30 per day. We know that Helen rented the car for 2 days. We know that they charge 15 cents per mile, so that's going to be 0.15. And we don't know how many miles she went, so we can just call that n or x or whatever variable you want. But her total was 108. So the 30 times 2, we can simplify that to 60, and we still have our 0.15 m equals 108. So there we go. We took what we knew and what we didn't know, we translated into a little bit of a verbal model and then an actual algebraic model, and now we have our equation to solve. So now we'll subtract 60 from both sides. 0.15 m is going to equal 48. And then when we divide by 0.15 on both sides, remember when you divide by a decimal, you get a bigger number. So we're going to get 320, and that would be miles. So when you're taking your quiz and your test, we're going to require you to write your answer in a complete sentence. So we would say, Helen drove 320 miles. Okay, our next problem is about interest. And interest is fairly basic. It all comes down to this equation where you have I for your interest, you have P for your principal, that's the amount that you originally deposit, you have R for your rate, and T for your time. And the rate, we have to make sure that we convert from a percent to a decimal. Now in example 2 here, we are dealing with interest and we're dealing with rate and time, but it's a little bit of a twist on the equation that we just saw. So let's read through it here. Mary inherits $100,000 and invests it in 2 certificates of deposit. That's what a bank calls a CD. One certificate pays 6% and the other pays 4.5% simple interest annually. Mary's total interest is $5,025 per year. How much money is invested at each rate? So we know how much money she inherited originally. That was our $100,000. We know she's got 2 different CDs or 2 different accounts that she's putting it into. We know one has a rate of 6% and the other has a rate of 4.5%. So she divides up her money. One goes into one account, one goes into the other. One pays 6%, one pays 4.5%. And at the end of a year, she made $5,025. So we want to figure out how much money she put into each account. So we really have 2 little parts going on here. We're still going to take the principal times the rate and the time, but that principal gets broken up. So how we have to think of this is that she has one account that's 6%. So we have one account at some rate, and she put some amount of money in there. We're not sure how much. And then she has another account with another rate, and she put some money in there too. And altogether, if we added up how much interest she got from each of them, we would end up with her total $5,025 in interest. So the first account paid 6%. So we want to change that from a percent to a decimal. So that's going to be 0.06. And again, we don't know how much money she put in there, so we'll just call it X. Now the other account pays 4.5%. So 4.5 is like 4.5. And if we change that to a decimal, we got to move the decimal, or we change that percent to a decimal, we move the decimal 2 places to the left. So that's going to be 0.045. Now we can figure out how much money she put into this account. Because if she had $100,000 altogether, she'd have to take $100,000 minus the amount she put into the other account to have the amount she's putting into this account. And when we add those up, it'll still equal 5025. So now we're going to distribute, and now we'll be able to solve for x. So we'll have 0.06x. Now if we take 0.045 and we multiply it by 100,000, we're going to get 4,500 minus the 0.045x equals our 5025. Then we can combine our x terms together. So 0.06 minus 0.045 will be 0.015x. And you can, again, do this in 2 steps like I'm doing, or you can do it in 1 step. But next we have to subtract the $4,500. So we have 0.015x, and that should be equal now to $525. And then when we divide, we'll get 35,000. So that's how much money she put into this account right here, this first account. Okay, the variable we had for x was the account for the 6%. So she put $35,000 into the account that was at a rate of 6%. And then to find out how much she put in the other account, we'll do exactly what we did up here. We'll take the 100,000 minus the x. So 100,000 minus 35,000 will be 65,000. And that's how much she put in the other account at the 4.5%. So again, on a quiz or a test, we would expect you to say, Mary invested $35,000 at 6% and $65,000 at 4.5%. So we want you to make a complete sentence. Okay, we have two examples left, and they both deal with area. And the nice thing about these types of problems is that they're based on geometry. You know a lot of these formulas for area, perimeter, area of a triangle, or Pythagorean theorem. So for these, we might not only need to draw a picture, but we might need to use a formula that we already know. So in example 3, we have a square garden. It has a walkway 3 feet wide around its outer edge, and that's what's drawn in the picture. So they've already drawn this for us, so we don't have to worry about drawing it, so that saves us a little time. If the area of the entire garden, so that's the garden and the walkways, the area of the entire garden, including the walkways, is 18,000 feet squared, what are the dimensions of the planted area, the actual garden? So again, if you need to read through this a couple of times, kind of restate it in your own words, you go ahead and do that. But the nice thing about this picture is that they gave us the dimension of the side length for the actual garden part. That's going to be x. And then they labeled the dimensions for the walkway. So we have 3 feet and 3 feet. So to get the whole side length for one whole side, it's x plus 3 plus 3. So one whole side length is going to be x plus 6. And you know that if we're dealing with a square, what makes a square a square is that the sides are the same. So if we know that the whole area of the walkway is 18,000 feet squared. And we know the formula for finding the area of a square. So basically we're doing area equals length times width. So our area is 18,000. Our length is going to be x plus 6, and our width is also going to be x plus 6 because we're dealing with a square. And when you have a square, the side lengths are the same. That's what makes a square a square. So when I distribute this out now, I'll have 18,000, and I'll have x squared plus 6x plus 6x, so that'll be 12x plus 36. Now, we could try and factor this. Actually, there might be a little more straightforward method for solving this. So I'm going to go over here and I'm going to rewrite this because if we had 18,000 x plus 6 squared, that might be a little bit easier to solve than what I have written over here. Because from here, I would have to subtract the 18,000 over, then I'd have to find the factors. So let's approach it from this angle, actually. So instead of doing this, let's rewrite it this way, because if I make it squared, then we just have to take the square root of both sides. And then we can subtract the 6, and then we'll have our value for x. So that'll be a lot less labor intensive. Now granted, when we take the square root, we're going to get a decimal. We're not going to have a perfect square of 18,000. So when you take the square root of the x plus 6 squared, you just get the x plus 6. The square root of 18,000, that's about 134.16. And then you subtract 6 from that. So x is going to be 128.16. So that roughly the area is about 128 feet by 128 feet. If you wanted to be super duper precise, you could certainly say it's 128.16 feet by 128.16 feet. But we'll just round to the nearest whole foot here. Okay, last one. dimensions of a building lot. Now this one we don't have a picture drawn for it, so we're probably going to want to try and use that strategy where we're going to draw a picture as we read through this. So we have a rectangular building lot. Well, I'm going to draw a rectangle then if it's a rectangle. So a rectangular building lot is 8 feet longer than it is wide. Okay, so here's my width, and this is my length, but it's 8 feet longer than it is wide. So it would be the width plus 8 to get my length. And it has an area of 2,900 feet squared. Find the dimensions of the lot. So now that we have our picture drawn, we can see the length and the width. We know the area. So again, this is going to be area equals length times width. So my area is 2,900. My length is the W plus 8. And my width is my width. Now this one I do want to distribute here. So I'll have W squared plus 8W. And I'm going to have to set it all equal to 0. So I'm going to subtract the 2,900 over. That way I keep the W squared positive. And now I'm going to have to use my calculator probably and play around with the factors of 2,900. See if I can figure out what times what is 2,900. That'll also add up to 8. So, little trial and error tells me that I need the factors of 58 and 50. 58 times 50 is 2,900. And if I make the 58 positive and the 50 negative, then it'll add up to a positive 8 and multiply to a negative 2,900. Then I'm going to set each of these equal to 0 and solve. So I'll have a width of negative 58, and then I'll have a width of 50. Now, which of those actually makes sense? You can't have a width of negative 58 feet, so that actually doesn't make any sense. So our width is going to be 50. And then when we plug the 50 in here and the 50 in here, we'll have 50 plus 8, so we do get that 58 back again. So my dimensions are going to be 50 feet wide by 58 feet long. And again, we would want to say that in a complete sentence in a quiz or a test. We would say the dimensions of the lot are 58 feet wide by 58 feet long. And there's a little trick too that I can tell you. If you don't want to waste a whole lot of time finding the factors of 2,900, take the square root of 2,900. The square root of 2,900 gets you close to 53. So that could tell you that your factors that are going to maybe add up to 8 might be in the 50s somewhere. So maybe try like 53 times what, or 52 times what. That helps you narrow down your trial and error a little bit. Now, in class, we are going to take a look at example number 5 in your textbook on page 61. So, if you have some time, look over that. Look at the example that's all worked out in the book. Read through that, make sure you understand it, because you're probably going to see some examples like that in the homework as well. If you have any questions, stop on in before school and see me.